Hello, everyone. Good morning, good afternoon, and good evening, wherever you are. I am Deekshant. I'm from Nepal, and it's about 9 p.m. in the evening here. Today, welcome to this webinar of Medical Scholar Board of WMI. Previously, we organized 3 webinars on research. First, we talked about starting research. Then, we discussed about different types of research. Then there was one webinar which talked about the use of AI in research. Now today, it's very important webinar on research that is about the medical statistics. So I'm not a statistician. I'm just a doctor doing my residency in dermatology. But because of my interest in research, I have been constantly learning about statistics, data analysis, and using them in the research. So today, we are going to talk about basic of the data analysis and basic of medical statistics, which we need to start our own research. Okay, let's go. So why statistics matter in medicine, especially if we are studying medicine, doing any study, why it matters? Because talking about medicine, it's about evidence. We are now practicing evidence-based medicine, and any evidence, any conclusion is drawn from studies, and they use data. They use the analysis of data, that's called statistics, to draw that conclusion. Whether it's about any medicine, for example, previously we used to use certain antibiotic. Now it is resistant, and we are using some new antibiotics. So how is that deducted, or how is that decided? It's based on the data. We analyze the data of the efficacy of that medicine against certain bacteria or certain causative agent. And that data showed that the old one is not effective against bacteria and the new one is effective. That's how we draw conclusion. So in every decision we take, there is some statistics. There is the role of some data, and it's very important for us. So while taking clinical decisions, like while diagnosing a disease, treatment choice, and communicating any risk, so we use the statistics. Another is very important, interpreting literature, because as we are interested in research, we'll need research for our higher education, for other opportunities, for getting global opportunities, for going to international universities. Research skills play an important role. So if we are studying research, then we need to interpret the literature. If you don't know the statistics, the basic of statistics, it's very difficult, to understand the research paper. It's boring also. But once we start understanding the data and analyzed in the study, analyzing the statistics part of that study, that paper, then we will love it. We'll start loving reading those articles. So it helps you to judge the study strength, bias, and relevance to patient. And another is patient communication. So we can use the data from our own hospital or from any literature to educate the patients also. These are just few uses of the statistics. Actually, statistics has many uses. Anything we study, anything we practice, that is deducted from some statistics. Okay. Statistics is not the obstacle between us and publication if we are doing research. It's our translator. Actually, it helps us to make our paper better. It helps us to get our paper published in a standard journal. So if we are starting a research, we already have the data. Okay. Every case series, every case report or chart review, or every quality improvement project we do in our hospital, we do in our setting, it produces data, not only numbers. Data doesn't mean only numbers. We can have other categorical data also. If we take interview with people, the answers they give, that is also data. And we can analyze them in particular way and present them in our paper. Statistics turns those number into a defensible claim. Actually, the whatever data we have in our hospital or in our practice, We can analyze them and we can present them in a presentable way in paper. That's the work done by statistics. Reviewers check this first. For example, if we send our article to any journal, the first thing they will check or review is the study methodology and the statistics. These two things they will review first, and they will decide whether to accept our paper in that journal or not. I have also reviewed many papers. They send me for reviewing the many articles from a few journals. And the first thing we see is the methodology part of the study. We have already done webinar on it. Another is the statistics. And actually, it's a talent. Statistics is a talent. If we start understanding statistics, we get a leading position in our group because only few people are so much interested in statistics as it involves mathematics. But it's not that difficult. Once we start doing it, practicing it, reading about it, it becomes familiar. And it's about continuous learning, We keep
No,
learning.
because
I've
currently now.
I'm involved in research since last 5, 6 years, and I'm still learning about statistics. It's so complex, it's vague, but if we know the basics, then we can write our paper. Okay, today we are going to talk about main four found things about statistics. One is the foundation of the statistics, the basics. What is that? What are the types of data? What do we mean by population and the sample? Another is how we describe the data. For example, we have data, then how we present it, how we describe it. Another is the few terms in the statistics like confidence intervals, p-values, and what statistical inference actually claims based on these values. And another is the choosing a test. There are two types of actually statistics or data presentation in the study. So one is the descriptive study, where we describe the data we have. We use frequencies, percentage, mean, median, mode, and describe our data. Another is the analytical study. Analytical study means we analyze the data. We find the relationship between two variables. We find out association or correlation between two variables. For example, what descriptive statistics means is like we have collected data about 300 people and their age. We describe their age by average or mean. That is the descriptive study. Then we uh, present their data as how many of them are male and how many of them are female. We describe their gender. That is the descriptive study. And analytical study means showing a relationship between any two variables. For example, the relationship between their gender and their weight or their marital status or their smoking habit. If we compare two variables and we show the relationship between two variables, we are doing analysis, and that is the analytical part of that study. And to do this, to show the relationship between two variables, so we use different tests, you know. So whether it is chi-square test or t-test or ANOVA, so these basics about the test will be describing in this session. Okay, we have already talked about this. Statistics are the language of research. Let's think statistics as the grammar that makes research readable. It helps us to describe the population clearly, to quantify uncertainty, and to decide whether the findings are likely due to chance or not, whether the finding of our study, whether the conclusion or the result of our study, it is just because of the chance or it is because of our study. So we use various numericals and various values to prove that. Now, this is very important. Every statistic is a guess about a population built from a sample. See, first of all, we need to understand what is population and what is sample. For example, we want to see relationship between smoking and blood pressure. For example, in people from Africa, in African people, then we cannot collect data from all the people in Africa. It takes a lot of time, lot of resources. So what we do is we collect a sample. First of all, we draw a sample from all the people in Africa. Maybe we draw few samples from each country in Africa and collect data from them. So sample is the subset of the population, but it represents the entire population. So it should be drawn in that way, that it is a representative portion of the population. So in this figure, this big circle is the population. And this small circle is the subset of that population, which is known as the sample. So there are various methods to calculate the sample size. If our study does not follow proper statistical method of sample size calculation, then our study will not be generalizable to the entire population. That's why it's important to calculate the right sample size, right number of the sample from the entire population. And based on the type of our study, or the based on the methods or statistics we are going to do in our study, there are various formulas to calculate the sample size. So since I am from Dharma, all psoriasis patients, this result should apply to. So if I use proper method to calculate the sample size and I collect the data from that sample, then the finding of this sample can be generalized or is applied to the entire population. So this is the statistical inference. See this line, a good sample is representative and adequately sized. That's what makes the inference trustworthy, not the formula. Now let's talk about the basic. What are the types of the data? For example, we may collect data interviewing someone, or we may prepare a questionnaire before collecting the data. So first of all, the data can be divided into numerical and categorical. So in categorical also, there are two. One is nominal, another is ordinal. So what do you mean by nominal? Nominal means it's named groups. There is no order. For example, uh, gender of a person. He can be either male, female, or else. And there is no order. There is no like we count one, two, three. But in nominal, it's not like male comes first or female. It can be in any order. So there is no order. Similarly, same for the blood group. Blood groups, there are few blood groups like A positive or B positive. There are few groups only. That's the category. They are the name, and there is no order. But in case of another type of categorical data, that is the ordinal one. Ordinal one means there is certain order in that different variables. For example, if we talk about disease severity, then it's mild, moderate, and severe. These are not numbers, these are categories, but there is order in categories. That's why it is ordinal. Mild, moderate, and severe. Similar in dermatology, we classify skin into six types. Fitzpatrick 1, 2, 3, 4, 5, and that's based on the color of our skin. So this is also in order. That's why it is ordinal. And there is one popular scale, we call it Leucott scale. We use in research where we are asking the participants questions like how satisfied you are. And there will be options like very satisfied to not satisfied. And in between there is satisfied, less satisfied, there are various order. So that's also ordinal. Now, these are the categorical, which are nominal and ordinal. Then talking about the numerical variables or numerical data, there are mainly two types of numerical data. One is discrete, another is continuous. In discrete, there are countable whole numbers like 1, 2, 3, 4, 5, but there will not be any decimals or fractions. But in continuous, there are decimal numbers also, like passage scores, age, duration of the illness. But in case of number of lesions or number of relapses, that's 1, 2, 3, 4. So discrete means it's a whole number. Continuous means those data which include decimals also. So the same thing. Uh, Nominal categories means these are the categories which have no order. Ordinal means these are the categorical variable that are ranked. They have certain order in them. Then interval means ordered with equal gaps, and ratio means there is true zero. So now there are two more types like interval and ratio. What do you mean by interval? Let's look at here. So interval is like there are equal intervals, but there is no true zero point in case of interval data. For example, in case of temperature in centigrade, see, there is no zero in if we measure the temperature in degree centigrade. In degree centigrade, 0 degree centigrade doesn't mean it's zero because there will be negative minus temperature also. That type of variables are known as interval variables. And ratio means there is true zero, like the uh, doses in milligrams. So if there is true zero, that's known as ratio. If there is not true zero, that's known as interval. And we already have discussed about this nominal and ordinal. So to summarize, uh, see, there are two types basically, categorical and numerical. Under categorical, nominal and ordinal are there. Under numerical, discrete and continuous are there. So why are these variables, these data are important? These are important if while analyzing and while representing the data in the research. For example, in case of categorical data, we show them in frequencies and percentage. For example, if we need to show gender of the our sample in the data, we show them as male and female and frequency and percentage. This number of male and percentage, this number of female. So in case of categorical data, usually we show them in percentage and frequency. And in case of numerical data, in case of discrete data or continuous data, we may use mean, median, or mode. And so that's why it is important first to know what type of data we are including in our study. Now, this is an example, right? So a small randomized trial in plaque psoriasis, 60 patients are randomized as 1:1, and one group is given drug A, another group is given drug B. Now, outcome is measured as one is continuous. Percentage of reduction in PASI score at 12 week, it is continuous variable. So it is shown in what percent of the people has what percent of the this PASI means psoriasis severity index, it is measured in number. What percent of this score is reduced? So that is continuous. And in case of categorical, if we represent this data as category, then responder versus non-responder. How many of them are responders and how many of them are non-responders? It is basically shown as categorical. So it is shown in number, it is shown in two categories. So same study, same result, we can present in either continuous variable, numerical variable, or categorical variable. Okay, after we know what type of data we have, then we do the descriptive analysis of them. So we'll be discussing about this graph later on. So if let's focus on this one. If our data is numerical, then we show them in various ways. One of the measure is the showing central tendency. If we include age of 300 people in our study, how to represent the age of 300 sample or 300 people. So age that is shown in the numerical scale, we represent them as either mean, median, or mode. These are the measures of the central tendency. And also, not all the people have the exact mean age. To show how spread our data is, we get the mean or median. Then from mean and median, how much the age is scattered among our sample. We use this by range or standard deviation or interquartile range. And we use visuals, histograms, or box plots to reveal those. For example, this is the mean. In this figure, this is the mean. This blue one, the center one is the mean. This is the mean age. So along with the mean age, we need to find out how dispersed is the data, how dispersed is the age. To show this, we use the standard deviation. So here, see this slide, mean, median, mode. Pick the one that isn't misleading. So one important thing we need to know is not all the data, all the numerical data is represented by mean only. We should know when to use mean in our data and when to show our data by median. This one is important if we are doing the research. For example, we collected our data on age of 300 people. And then how to decide whether we should use mean or median to represent the data. So there is something known as normal distribution. So we need to first check whether our data is normally distributed or not. So what is normal distribution? So this curve here, it is known as the Gaussian curve. So normally distributed means if our data falls under this curve area, that's known as normal distribution. And if our data is normally distributed means the data are equally distributed around the mean. There are no much dispersion from the mean. Then we can show by mean. But if our data is not normally distributed, that means some data are very small and some age, for example, some age is very small and some age is very large. Very, if we take data, the youngest person is 2 years and the oldest person is 99 years, but our mean is 14 years. Sometimes it may come. So that means that 99 is an outlier. The data is very dispersed and it is not normally distributed. And in those cases, we have to represent our data by the median. So symmetrically distribution, mean is equal to median. So we can see the median. But in case of skewed distribution, if the data is not symmetrically distributed, in that case, mean is not equal to median. So the same thing, let's see the example here. See, there are two sets of data, systolic BP readings, 120, 122, 125, 180. Another set of data, 118, 121, 124, 127. So in the second case, see, all these data are they are distributed in equal gap, like 118, 121, 124, and 127. If we use mean in this data set, then this mean will represent the whole data. But in case of first data set, 120, 122, 125, and 180. That means 180 is very higher than these three datas, and the mean will be pushed towards the higher side by this data. That's why it is known as outlier. And representing this data with mean will not be appropriate in this case, and we have to use the median or mode. Usually we use median in this case. That's why, first of all, we need to look how our data is distributed, whether it is normally distributed or not normally distributed. And there is formula and there is softwares to find out that. So mean is very sensitive to outliers, means if the data are not distributed in equal gaps, then that will affect the mean of the data, and it is not suitable to represent that data set with mean. But median is robust. It better represents the data that are not equally distributed. So the average alone can lie. Split tells you how much to trust it. So if we just represent our data with mean, sometimes it may lie because of the role of the outliers. That's why we have to use how much data is distributed, and we use a range, means maximum minus minimum, and standard deviation that shows how much the data is distributed around the mean, and interquartile range in case of median. So these are the dispersion measures of the dispersion. And along with the measures of the central tendency like mean, median, and mode, we also need to use appropriate measures of dispersion to show our data, to represent our data. See, the same thing, standard deviation, it shows how much our data is distributed. For example, in this figure, if this central value is the mean of our data, then within the 95% area from the mean, two standard deviations are located. And within the 68% uh, from the mean, one standard deviation is located. See, we might have read about mean plus minus a standard deviation. So this is what it represents. See, this is the same curve I have shown you. The normal distribution, why so many tests assumes this bell shape. So this is the mean, and these areas are the distribution from the mean. For example, if we show the data by the mean, then these other areas shows how much data are scattered around the mean. If it is 68%, that is the first SD, mean plus minus one standard deviation means it contains the 68% of the values, and mean plus minus two standard deviations means it contains 95% of the values of the data, and mean plus minus three standard deviation means this area under the curve, it carries about 99.7% of values of our data here. So before choosing which test to apply to analyze our data, we have to find out whether our data is normally distributed or not. If it is normally distributed, we use certain test. If it is not normally distributed, we use another test. So many common tests like t-test, ANOVA, Pearson correlation test assume that our data is normally distributed. That's why we need to check them whether our data is normally distributed or not. When our data is not normally distributed, then we cannot apply those common tests. We have to apply another test because the skewness, that means the distribution of the data, not normal distribution of the data, that will change the nature of the representation. If our data is skewed, that means if it is not symmetrical or it's not normally distributed, then we need to use median and interquartile range in place of mean and standard deviation. We've already discussed about it. And we will prefer non-parametric test instead of the parametric test like a t-test or other test. And that's why it is very important to find out whether our data is normally distributed or not. Then, according to our data, we use different kind of visualization tools to visualize this. We use bar diagram, we use histogram if it is continuous. If it is categorical, then bar diagram. To show the median central tendency and dispersion around it, we can use this box plot diagram also. So based on the type of our data, we can visualize it. There are many other tools to visualize it. We can use pie charts also. We can use tabular form also. So these are the basic tools of the data visualization, or in which we describe our data. Now let's talk about another thing that is known as the margin of error. Every estimate needs a margin of error attached to it. See, if we do the research, we are not 100% accurate because there are many errors that come while doing the research, where the manual errors or errors of the tools or the machines we do, or errors because of the people, or if we are taking interview, they may forget something. All these are covered by the margin of errors. And we describe them as confidence interval also. This is the basic. Actually, if we keep learning about this standard error, p-value, confidence interval, a type A error, type B error, this will take long classes. Today, I'm just going to sensitize all of you regarding the basics of the statistics. Okay, confidence interval is not just a number. For example, this line, drug A reduced psoriasis score by 62%, 95% confidence interval, 54 to 70%. So what it correctly means, if we repeated this study many times, 95% of the confidence interval calculated would contain in the true population effect. For example, I did this research here in Nepal. Then my research gave this result. Drug A reduced the score of the psoriasis by 62%, 95% confidence interval, 54% to 75%. If you do the same result in Africa, then there also this 95% uh, this 95% of the confidence interval means 54% to 77. There will be chance of 95% that the result will fall under within the 54% to 70%. So what it does not mean is there is 95% probability that the true value lies in between 54% and 70%. So this is not true. 95% confidence interval, it shows that if we repeat the study, then 95% of the confidence intervals calculated, that is 54 to 72%, would contain the true population. Now, the p-value answers one narrow question. If there were truly no difference, how unusual would data be like? We all have read about the p-values, like p is less than 0.05, p is more than 0.05. What does it actually means? So it doesn't mean p equal to 0.03 does not mean that 3% chance the drug doesn't work. It is not that. Okay. What p equal to 0.03 means that this extreme would occur 3% of the time if there were no effect. For example, let's talk example of smoking, a relationship of smoking with BP. For example, we find out that smoking is related to uh, hypertension is related to smoking with p equal to 0.03. It doesn't mean that there is 3% chance that smoking is not related to blood pressure. It means that p equal to 0.03 means that if there were no any relationship between smoking and hypertension, then hypertension will naturally occur in 3% of the time, of only 3% of the time with the smoking. So p-value shows how what percentage of the relationship will occur if there was no relationship between the two variables, or it shows the probability that happens by nature or by chance. So p is less than 0. Proves clinical importance. P is less than 0.05 only says the result is unlikely due to chance. It is not due to chance. Effect size shows importance. So whatever number of p-value is there, it means that that percentage of the relationship will occur by chance. So that's why to prove our result to be statistically significant, there should be at least p-value which is less than at most, there should be maximum 0.05 or less than that to prove our result that is statistically significant. I know this is a bit confusing for you if you are studying it for the first time. That's why to you can do more research in the AI to explain this. It takes a little bit of familiarity to understand what p-value means. I'm finding it more difficult to explain you exactly what does it mean, though I have figured it out inside me. So the way we normally feel that p-value is a certain percentage of the finding, it is not true. P-value means uh, the percentage of our result to be happened by chance, not because of the relationship between two variables or the because of the effect of our study. Let's understand this slightly. Now, another important thing while doing the data analysis is the test. So how do we apply test? This slide is very important. This is the decision tree which correlates to different tests. First of all, what is our data? What is our variable? Whether it is categorical, like nominal or ordinal, or it is continuous. If it is categorical, If there are two groups, uh, only two groups, then we apply the chi-square test. For example, if there are people who have smoke, if we see the relationship between two variables, smoking and hypertension, and we divide into four, uh, two into two box. So there will be people who have smoking, who do smoking, and who do not do smoking, and there will be people who have hypertension and who do not have hypertension. So we are showing the relationship between two variables. In that case, we can use chi-square test. And there is another test known as Fisher's exact test. If the value of any cell in that 2 into 2 table is less than 5, then instead of the chi-square test, we do Fisher's exact test. For example, if we compare between responder versus non-responder or drug A versus drug B, then we use chi-square test. And if we have the categorical data, if we have the categorical variable, and there are more than three groups, then there also we use chi-square test of independence. But if we have the continuous data, like numerical data, discrete data or continuous data, then we have to check. I have already talked about it, whether that numerical data is normally distributed or not, if the curve is symmetrical or not. Then, if it is normal, if the curve is symmetrical, then if there are two groups of the data, then we use independent t-test. For example, if we try to find the relationship between age of the people and their blood pressure, systolic blood pressure, both of them are numerical, right? And if we have to see the relationship between these two numerical data, first we need to check whether these are normally distributed or not. Then if they are normally distributed, they are just two groups. That's why in that case, we need to use the independent t-test. If these data are not normally distributed and there are two groups, the same age and blood pressure, if they are not normally distributed, then we use Mann-Whitney U-test. These are for the two groups. If we are going to see relationship between three numerical groups, then we use something known as ANOVA if it is normal, or Kruskal-Wallis test if it is not normal. And for seeing the relationship between two continuous variables, we use the correlation. Pearson and Spearman, again, on the basis of whether it is normally distributed or not normally distributed. So this slide shows the entire analysis of the analytical study up to the showing the associations or relationship between two variables. Okay, uh, this is the summary of today's class. 5 things to carry out of this room means if we are doing the research and if we have collected our data, if we have entered our data, then before starting the analysis of our data, we need to identify what are the variables in our data, whether it is categorical or numerical. In categorical also, there are many two types, nominal or ordinal, and in numerical, whether it is discrete or continuous. Then if our data is symmetrical, in case of numerical data, if our data is symmetrical or normally distributed, to describe it, we use mean with or without standard deviation. If it is not symmetrically distributed or if it is skewed, then we use median and interquartile range. A confidence interval is more informative than a p-value alone. So please once again go through this p-value and confidence interval. It takes a bit familiarity to understand what this actually means. P less than 0.05 is not proof. Pair it with effect size and clinical judgment. When in doubt, consult a biostatistician before data collection. So today's class is just the basic about the statistics. So I have been in research in 6 years, but I am not confident in doing many analysis because there are a lot of complex calculations in the statistics. But I can do the descriptive one, basics of the analytical ones, and regression one. So whenever we have the doubt, we need to consult a biostatistician because if our research does not present our data in statistical accuracy, then it is not a good research. So this much for today. I know it's a very complex topic, mathematical, and very difficult to understand if you are going for the first time. So in summary, I'll tell you, if you have collected the data, first know how can you present the data, whether you are going to present it in categories, and there are a few variables that need to be presented in the numbers. We can just have a common sense and find out. If we are presenting the gender of a person, then male and female, these are categories. If we are presenting the age of a person, that is a numerical data. If we are presenting the location or the address of someone, then that is also categorical data. If we are presenting their blood pressure, that is numerical data. If we are asking them whether they smoke or not, smoking and not smoking, again, this is the categorical data. But if you are asking them how much or how many cigarettes they use per day, then that is the numerical data. So we can find out whether our data will be categorical and numerical. Then categorical data, we can describe them in frequency and percentage. For example, if we are presenting gender of our sample, then we can present them as male and female, frequency, number, and percentages. If we are presenting the number amount of smoker and non-smoker in our data, then we can again use the frequency and percentage. So for all the categorical data, you can either present it as frequency and percentage in a table, or same frequency and percentage you can present in the bar diagram. Okay, this is for the categorical data. But if our data is numerical, if we are presenting the age of the person, if we are presenting the number of cigarettes they have been using or the pack year of the cigarettes, then for the numerical data, before analysis, we have to find out whether it is normally distributed or not. Normally distributed means this is equally distributed around the mean. Not normally distributed means there is outlier. There are some values which will distort the average or mean of that data. Then if it is not, if it is normally distributed, we represent the data with mean and standard deviation. If it is not normally distributed, then we present it with median and interquartile range. Then, on the basis of the normal distribution or not normal distribution, we apply the tests. And we have already discussed about these types of the tests. So I think you will know a lot of things before you jump into the test. You already know a lot of things if you know how to apply these tests and the name of these tests. So as today's session is about the basic of the biostatics, I think this much is enough. A lot of information, if we deliver at the same time, we'll not be able to grasp them. So thank you very much for listening to me. Let's ask you, please ask your question if you have any. Any questions? You can either chat. Okay, thank you. I have any? You can also ask in the WhatsApp group. I will answer whenever I will get time to answer the questions, because statistics is very difficult. It's a very complex. People spend years just to study and master the statistics. But to understand basics, if we understand basics, we can publish our paper.
Hello, Deekshanta. Can you hear me?
Hello, hello, Justice.
Okay, thank you so much for the presentation. Yeah, it was complex, but it just kept bringing back memories from while I was taking statistics class in school. So I have a question when it comes to using different softwares for analysis. I know when I was writing my project in school, my supervisor told me to use GraphPad instance for the analysis aspect. So how does one know which software to use for analysis, which software to learn? How do I pick a software to master over the others? So does this have to be on the type of research I'm carrying out? So I'd just like to know. Thank you.
So Justice, are you asking about what type of figure or diagrams do you use or what?
No, what type of software, analytical software
Analytical, can you type it?
that we have?
So Deekshanta, I think he wants to know
So many out there, like
I think,
GraphPad.
I think he wants to know what type of, how do you determine which statistical tool, for instance,
Yeah.
theta, R, or
So yeah,
Okay. Yes.
Epicsta? I
Yes. Yes.
mean,
Yes. Okay. Okay.
what determines
Software.
which
You mean
tool to
software? Oh,
use?
I now I
Yeah.
get it. Thank you. Thank you, Isaac. Thank you, Justice. So, yes, you can use any one of them if you know how to use them. For example, I use SPSS. I used to use SPSS. You might have heard about SPSS. So that was crack version. If we need to use it, then we need to pay. But we use cracked version from the torrent. We downloaded the cracked version, the pirated version, and we used it. Then you can use also R if you know how to use it. And another is there is one another free software. I'm typing it that is known as JASP. So I have written it in the chat. So JSP is a free software. You can use that also. It is not pirated. It is not, you can use it for free. You can download and use it for free. So all these softwares, they do the same thing. They will calculate mean or median or mode. They will calculate the chi-square test. They will do the t-test and show the result to us. So anything is fine. Any tool is fine if we know how to use it. So we can master in any one tool. Uh, in my medical school, I was taught initially to use the SPSS and I use it. Now I have in my residency, they are teaching me in statistics this tool known as JASP, which is a very good tool. And nowadays I am using it. So you can use any one of them because all these tools, they do the same thing. They will calculate the results for you. You just need to master that tool, and now it's easy actually, because there are lots of tutorial videos in the YouTube. And if you get confused in some steps, you can ask ChatGPT also, what am I missing right now, and they will tell the answer. So any software, and if you are sourcing for the free software, there is JASP. Actually, it was started by the professors at University of Netherlands, I guess, for their students, and it's free to use, and it's not illegal version. It's a legal version, non-pirated version. We can use it, and it's easy. So anybody else? Any question?
okay. Thank you so much.
Hello, Deekshanta, can I make a comment?
Yeah, please, please.
Okay. So concerning the question Justice asks, I also think that sometimes it depends on what your institution require of you. I remember
Yeah,
when I was doing my undergraduate studies, my project, we were asked to use SPSS.
yeah,
But now I'm doing a master's in global health and non-communicable diseases, and my institution wants us to use data. So sometimes it depends on your institutional requirement as to which statistical tool you need to use. But that notwithstanding, all boils down to your ability to use that statistical tool or analytical tool. I mean, any tool you feel you're comfortable, which can get the work done, you can use it. It will surprise you to know that even Excel is a very good statistical tool once you are able to understand the formula, and once you're able to apply the formula when need be, you can use it to analyze your data, and it gives brilliant results. It all boils down to how conversant you are with that particular statistical tool, then you can get the work done. So yes, Sometimes it depends on your institutional requirement. Sometimes you just need to choose it out of your free will, depending on whether you are able to use that statistical tool or not. Yeah. Thank you. Over to you, Deekshanta.
Thank you, Isaac. Yes, you're true. Like sometimes our institution will themselves say, please use this tool. If it is predetermined, then we can use that tool. So if there is no question, then Isaac, I think we can conclude the session for today.
Absolutely, absolutely. We want to thank our speaker, Dr. Deekshanta, very, very much for this exciting presentation. I've personally learned a lot. I'm actually doing my project work, and this came very, very handy. I've learned a lot, which I'm going to apply in my data analysis phase. Thank you so very much, Deekshanta, for this yet amazing, yet insightful presentation. We want to also once again thank all our attendees. I can see Dr. Onisai, we have Mary, we have Ahmed, we have Bernadette. Thank you so very much for taking time out of your busy schedule to join this session. We believe and hope that you learned a lot, just like how I personally learned a lot. We want to assure you that the video we made available in the course of the week, we are also going to share with you the presentation slides so that at your free time you can once again go through and learn again. So thank you very much. Um, Once more and hope to see you. For those of us who be coming to Nairobi from the 22nd, hope to see you in person. There's going to be a medical scholar meet and greet. I hope to see you all there so that you can get to know each other on a personal level, get to interact, get to socialize, as well as get to network. So once again, thank you very much. Because of the Dream Make conference, this is our last webinar session for the month. Hope to see you next month after the Dream Break conference. So thank you very much and do have an amazing week ahead of you. Okay. All right. Bye.
Thank you very much. Bye bye.